integrals can be indefinite or definite. So here we have an example of an indefinite integral of the function cosine x dx. To evaluate this, all we need to do is we need to find one antiderivative of this function cosine. So we know that sine is an antiderivative of cosine, so this indefinite integral is simply equal to one antiderivative plus c, where c is any constant. On the other hand, we have definite integrals, and here we have proper and improper definite integrals. So this is a proper definite integral because the limits of integration, so 0 and pi over 2, are proper real numbers. And the function that we want to integrate is a continuous function. So here is when we can use the fundamental theorem of calculus. And to evaluate this proper definite integral, all we have to do is we need to find one antiderivative of this function cosine. So again, we know that sine is an antiderivative, and then we evaluate this function sine first at pi over 2, because this is the upper limit of integration, and then at 0, the same antiderivative but at 0, because this is the lower limit of integration. So we know that this is 1 and this is 0, so the proper definite integral is 1. When one of those two limits of integrations, or possibly two, are infinite, like in this example, so here we have definite integral, but it's from 1 to infinity. The upper limit of integration is improper, so this integral would be classified as definite improper integral. And here we'll discuss a couple of examples of improper definite integrals. So consider the function 1 over x squared, which is the same as x to the negative 2. And let's say that we want to integrate this function from 1 all the way up to infinity. So we want to evaluate this area of this region. So what we can do is we can fix some parameter t, which is bigger than 1, and then we can integrate this function from 1 up to t. So we can integrate from 1 up to t of this function 1 over x squared, which is x to the negative 2 dx. And then what we do, we'll take the limit of this expression when t goes to infinity. We'll compute the limit of this expression when t goes to infinity. So that's exactly what the initially given integral is equal to. So let's evaluate this limit. This is equal to the limit when t goes to infinity. Antiderivative of this function is negative 1 over x, and we'll use the fundamental theorem of calculus. So we want to know what this function is equal to at 1, first of all, and then what this function is equal to at t. This is the upper limit of integration, and then we'll compute the limit of this expression. So first of all, this is the limit t goes to infinity, this function at t, so that's negative 1 over t, and then minus the same function but at 1, so it's negative and negative positive 1. And the limit of this expression when t goes to infinity, this goes to 0, so the whole expression is 1. The limit is 1, and what it means is that the area of this infinite region A is equal to 1. So consider again the same function 1 over x squared. Function is the same, but now let's integrate this function from negative infinity up to negative 1. So from negative infinity all the way up to negative 1. That's the region of interest. So I want to evaluate this integral, and I can do so exactly in the same way. I can fix a parameter t that is less than negative 1, and then I can integrate this function from t up to negative 1. So let's do so. Let's integrate the function from t, so from from this point t all the way up to -1. So here it's -1. And the function is 1 over x squared, which is the same as x to the -2 dx. And then what we do, we'll take the limit of this when t goes to -infinity. So it's going to be limit t goes to -infinity. That's exactly what the initially given integral is equal to. So let's compute the limit. This is equal to, and limit t goes to -infinity, and this function will evaluate by the fundamental theorem of calculus. Antiderivative of this function is -1 over x, and I want to know what this function is equal to when x is equal to t, so that's this point, and then when x is equal to -1, that's this point, first at -1. So it's equal to limit t goes to -infinity, and then this function at -1, this is negative and negative positive, so this function is equal to 1, and then minus this function at t, minus and minus positive 1 over t. And it's easy to compute the limit of this expression because this goes to 0 and the whole limit is 1. So what it means is that this region, area of this infinite region, is equal to 1.